Kia ora, Year 12 and Year 11. I'm going to start going through some more algebra questions now. This one's from 2014 and it's got 3 parts to it and they're all about tunnels. So it goes like this. I'm going to put all of the questions up here first and then split them out a bit. In the first question, we're told, this is a merit question, we've given the height in meters of a tunnel is given to us by this functional form. And this is kind of like a warm-up question, except that because it's got no numbers in it, it's actually quite abstract. And what we're looking at here is x is going to be the distance in meters from the left side of the tunnel, and we have to make that the subject of the equation. So I think the reason this question's here is because it gets your brain thinking about how can we model a tunnel. And we can model it as an upside down parabola. Right? So if this is the distance from the left side of the tunnel, our tunnel picture could look like that. Here's x and here's h. And that idea is going to lead me all the way through these questions. Okay, but to make x the subject of the equation, I need to work with the quadratic formula. So I'm going to do that question first. We're given h is equal to r x squared minus tx. To solve a quadratic, I need to have it equal 0. So we get rx squared minus tx minus h equals 0. Right, a is equal to r, b is equal to negative t, and c is equal to negative h. Notice that you can't just chuck this in your calculator. You've got to show a little bit of understanding of how the quadratic formula can help us. So this is my quadratic formula. Pop that down first, and now substitute so that you don't muck it up. So x is equal to t plus or minus negative t squared will give me t squared. Be careful with that, right? It's negative t squared minus 4 times r times, I think I might be meant to have, times negative h, divided by 2r. So x is t plus or minus this t squared plus 4rh divided by 2r. So there we go, there's that one done. I actually didn't use that again later in the question, but you could have. You'll see when we get there how you could have used it. Now let's go on to the next 2 questions. Oh, that's the wrong one. Here they are here. Okay, so the shape of the tunnel can be modelled by a parabola. The maximum height of the tunnel is 6, and at ground level its width is 12 metres. Find the equation of the parabola. As usual, if we do a nice graph, this question is straightforward. If we don't do the nice graph, it's not so good. So I'm going to draw, I'm even going to use a ruler for the graph, just in case anyone proper is watching. Let's see, there we go. So you get your ruler and draw your axes. And the parabola is going to go like this. So it's going to start here and go whoomp like that. Right, we've been told what? It is 12 metres wide and the maximum height is 6. We know that parabolas are symmetric, so let's mark on the x-intercepts. And the value of x where it's at its peak height, maximum height, will be x equals 6. And we know that the maximum height is 6 metres. This is y or h. So what we need to do is to figure out the equation that we can use to model the width of the tunnel. It's going to have this form. Y will be equal to some stretchy factor, and my 2 intercepts are 0 and 12, so it's going to be kx times x minus 12. We know that 6 is on the curve. So to find the value of k, we're going to substitute that point in. 6 is equal to k times 6 minus 12, negative 6, giving me k is equal to 6 over negative 36, which is negative 1/6. So the equation of the parabola that we can use to model the tunnel is negative 1 over x, negative 1/6 x times x minus 12. So that's the first part of the problem solved. Let's look at what we have to do with that now. Okay, this next bit looks bad, but it really isn't, and they've even drawn you a nice picture. The outside edge of each lane is marked by a line so that a car of height 1.8 metres would have a minimum clearance of 0.1 metres vertically. In other words, we want to figure out where is this height here, not 1.8 metres, but 1.8 plus a bit of wiggle room plus 0.1. So just read questions like this really slowly. Think what would happen if you went the wrong way and you had a 1.7 metre height here. You'd have car crashes. Okay, so what we have to do is figure out what is this value here. We've got the same thing on this side here, and we've got two lanes. So we're going to go to the middle of my tunnel, which is at 6, and we're going to work out that width or that one because they'll be equal. So putting that into maths terms, what we're doing is we're solving the following equation. We want to figure out where is the height 1.9. So we've got 1.9 is equal to negative 1/6. I'm going to expand at this point and do this. So negative 1/6 x squared plus 2x. So 0 is equal to this. I could put it into the quadratic formula at this point, but I would much rather just clean it up a little bit. If you've had me for a teacher, you'll know that I hate working with quadratics where I've got a negative term here. So I'm going to multiply the whole thing through by negative 6, giving me x squared minus 12x plus 1.9 times 6 is 11.4. Right, so you don't have to do that. But if we now substitute those values in, we get x equals 12 plus or minus 144 minus 4ac over 2a. And that gives me two values of x, 1.04 and 10.96. Now you should be really happy if you got to that point because they make complete sense in the context of this problem. It's telling me that here's my tunnel. We want to put the edge of one lane there and the edge of the other lane there at 10.96. The middle is at 6, so each lane is how wide? Well, it's going to be 6 minus 1.04 metres. What does that work out to be? 4.96 metres, and that's to the nearest centimetre. Okay, there you go. Leave me a question in the comments if that doesn't make sense, but it's a really nice question, and it is worth going over the ideas you learnt in tables, equations and graphs in Year 11 for the algebra paper. Thanks for watching.